Hi everyone. In today's lesson we're going to look at finding the perimeter, circumference, or area of some basic shapes. Remember, perimeter is the distance around the outside of a figure, and it's found by adding all of the sides together. The circumference is the distance around a circle, so it's very similar to perimeter. The area is the number of square units that a surface covers. So perimeter is distance around the outside, while area is covering the surface. Remember that area is always measured in square units. In other words, it's the number of squares that it would take to cover a surface. Some of our common formulas are listed on this page. Remember, a square has four sides that are equal. So to find the perimeter, we add all four sides. Or another way we could look at this, we could call all sides S, so S plus S plus S plus S could also be written as 4S. Remember, area of a rectangle is length times width, but in a square the length and the width can be called the same thing. So S times S could be restated as S squared. Notice in the perimeter of a rectangle we could say base plus height plus base plus height, or 2 times the base plus 2 times the height. And the area of a rectangle is found by multiplying the base and the height together. In a triangle, we simply add the three sides of the triangle together to get the perimeter. A triangle is half of a rectangle, or half of a parallelogram, so it's 1/2 base times height to find the area. But remember, the height is always measured at a right angle to the base. So in this triangle, B is the base and H is the height. The height does not have to be a side of the triangle. And in a circle, the circumference is found by multiplying pi times the diameter. Sometimes that's written as C equals 2 pi r, but remember, 2 of the radius is the same as the diameter. And the area is pi multiplied by the radius squared. So we're going to be using these formulas today. In our first problem, we see that we are looking at a rectangular garden. It says the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. The key here is it says outside. Outside indicates that we're looking for the perimeter. We want to edge the outside. How much edging material will they need? We're given some numbers here, but we're actually asked to find the outside, which is along the entire shape out here. So we need to find the lengths of each of these sides. Notice we're told that this is 22, but that's not the length of the entire side. However, we do know this. If that's 22, then the distance right here, this is 22. We know that this is 4 feet right here. So we have 4 feet at the top, and we have 4 feet at the bottom. And we have 22 feet in the middle. So if we add 4, 4, and 22, we see that this entire distance is 30 feet. Now we can do the same thing to find the length across the bottom. The sidewalk is still 4 feet wide on the sides, so this would add 4 feet on the left and 4 feet on the right, meaning that along the bottom we have 4 feet, 16 feet, and 4 feet, or 24 feet. So if I wanted to find the perimeter, I would simply add 30 plus 24 plus 30 plus 24. Or you could write this as 2 times 30 plus 2 times 24. If I add those together, I get a total of 108. So I see that they should use 108 feet of edging material. Please remember on a word problem to make sure that you use your units. Our next problem involves looking at some circles. Notice we're asked to find the circumference of the circle in terms of pi. In terms of pi simply means we're going to leave pi in the answer to the problem, and we're not going to evaluate it. So circumference is found by taking pi times the diameter. In this circle, the diameter is 15. So the circumference is simply pi times 15, or 15 pi. And that's measured in inches. The second part of the problem, however, says what's the circumference of the circle to the nearest tenth. So now we're going to take 15 times pi on our calculator. And if I multiply 15 times pi, I get approximately 47.12, which rounded to the nearest tenth, 47.12 would be 47.1 inches. So notice the difference between these two answers. If you're asked to leave something in terms of pi, then do not evaluate pi. If you're asked to find it to the nearest tenth, then go ahead and find pi on your calculator and take 15 and multiply it by pi. Letter B, the circumference is again pi times diameter. Keep in mind the diameter of the circle is not 4. This is the radius. So the diameter is double that number, or 8. So the circumference is pi times 8, or 8 pi centimeters. For my second answer, I'm again going to find this to the nearest tenth. So if I multiply 8 times pi, I get 25.13, which is approximately 25.1 centimeters. In our next problem, we're asked to graph quadrilateral JKLM with vertices at -3, -3, 1, -3, 1, 4, and -3, 1. So at this point in your notes, go ahead and graph each of those points on the coordinate plane. You can pause the video while you do that. Once you've had a chance to graph each of those points, we're going to look at finding the perimeter of this figure. In order to find the perimeter of this figure, we need to know the length of each of these sides. Keep in mind that as long as a segment is vertical or horizontal, you can easily count the units. So from M to J, I can easily count to be 4 units. From J to K is again 4 units. And from K to L, we can count and find that it's 7 units. However, I cannot count from M to L, so I'm going to need to find the length of this segment. The way I would do that is I would go back to my distance formula, and ML is going to be found by finding the distance using x2 minus x1 squared plus y2 minus y1 squared, and then finding its square root. So if I substitute my numbers in, I'm going to use L to be x2 and y2, and M to be x1 and y1. I would take the square root of 1 minus -3, or 1 plus 3 squared, and 4 minus 1 squared. So we now have 4 squared plus 3 squared, and 4 squared is 16, 3 squared is 9, and I have the square root of 25. Since the square root of 25 is 5, I know that the distance from M to L is 5 units. And now I can simply find the perimeter by adding the lengths of the 4 sides together. So 4 plus 4 plus 7 plus 5. That would be 8 plus 12, or 20 units. So the perimeter of JKLM is 20 units. Our next example says that we're designing a poster that's going to be 3 yards wide and 8 feet high. And we want to know how much paper we need to make the poster. And we're going to give our answer in square feet. So let's start with a picture. Notice it says to give your answer in square feet. That tells me two things. Number one, the fact that it's squared lets me know that I'm definitely finding the area. I also notice that I want it to be in feet. The top side of the box is listed in yards. I need to convert that to feet. There are 3 feet in every yard. So if I have 3 yards, I would have a total of 9 feet. To find the area of a rectangle, I take base times height, or in this case, 9 feet, and multiply it by 8 feet. 9 times 8 is 72, and so this would be 72 square feet. So you need 72 square feet of paper. Remember, units are important on these problems. In our next example, we're again looking at a circle, but this time, instead of being asked to find the circumference, we're asked to find the area. So on A, the area of a circle is found using pi times radius squared. The diameter is 14 feet. If the diameter is 14, remember the radius will be half of that, so the radius is 7. I substitute that into my formula and find that I have pi times 7 squared. And 7 squared is 49. Letter A says to leave my answer in terms of pi, which means I'm going to leave my answer like this. I'm simply going to switch it and call it 49 pi square feet. And remember, since it's area, I have square feet. In letter B, I'm asked to find the area using an approximation of pi. I've already done the rest of the work. Now I simply need to multiply 49 times pi using my calculator. And 49 times pi is approximately 153.93. If I round to the nearest tenth, as in the other problems, I will now have 153.9 square feet for my area. Postulate 110 is the area addition postulate, and it simply says that the area of a region is the sum of the areas of its non-overlapping parts. In other words, if you have an odd-shaped figure, you can cut it into shapes, like into rectangles or triangles, and then simply add the areas of those regions together. One way to do this problem would be to cut each of these into rectangular slices vertically. I've now changed this into 3 separate areas. I'm going to call them Area 1, Area 2, and Area 3. Notice that for Area 1 I have a rectangle that has a length of 3 and a width of 9, or a base of 3 and a height of 9. So Area 1 is base times height, or 3 times 9, which is 27 square centimeters. For Area 2, I notice the congruent symbol here tells me that this is 3 centimeters. The height is 9, take away 3, because I know that this distance is 3. and the whole distance is 9. So this distance here must be 6. So my base is 3 and my height is 6. Or 18 square centimeters. For area 3, I notice both of these are marked congruent to the 3 up at the top of the figure. So the base and the height on the third are both 3 centimeters. So area 3, we can use base times height or side squared. It doesn't matter, because either way I'm going to be multiplying 3 times 3, which is 9 square centimeters. So if I want the area of the total figure, I simply add 27 plus 18 plus 9 and get a total of 54 square centimeters. In our last example, we notice again that we have an odd-shaped figure. I can cut this, however, horizontally, and then I would have a rectangle and a triangle. I'm going to call my rectangle area 1 and my triangle area 2. To find the area of a rectangle, we take base times height. In this figure, the base is 12 feet and the height is 4 feet. So the area of the rectangle is 48 square feet. The area of a triangle is found by multiplying 1/2 times base times height. I can see that the height of this triangle is the same as the height of this rectangle, so I can call that 4 feet. The base of this triangle is the dotted line across the bottom, and the reason I know that is since I have a right angle on the left, that's a right angle, and the base and the height form a right angle. This length can be found by taking the length of the entire segment, which we know to be 12, and subtracting the length of the smaller segment on the left, which is 4, and 12 minus 4 is 8. So the base of the triangle is 8 feet, and my area is 1/2 times 8 times 4. Or 8 times 4 is 32, so half of 32 is 16. And that would be 16 square feet. If we add the areas together, we find that this is a total of 64 square feet. And that's the end of today's lesson. I'll see you in class tomorrow.